The Connecticut Journeyman Electrical Exam is a computer-based exam consisting of multiple-choice questions. The exam has a total of 125 questions. The content is broken down into four main areas. Firstly, OSHA regulations comprise 15 to 20% of the exam, covering topics such as personal protective equipment or PPE, electrical safety requirements, job site safety, and lockout or tagout procedures. Secondly, electrical theory accounts for 50 to 60% of the exam and includes basic electricity principles like current, voltage, and resistance, alternating current or AC and direct current or DC circuits, electrical equipment such as transformers, motors, and generators, and electrical codes, specifically the National Electrical Code or NEC. Thirdly, electrical calculations make up 15 to 20% of the exam, focusing on Ohm's law, power calculations, wire sizing, and circuit analysis. Fourthly, troubleshooting and repair constitute 10 to 15% of the exam, covering electrical system diagnosis, troubleshooting methods, and repair techniques. To prepare, consider these tips. Firstly, study the National Electrical Code or NEC, as it is a fundamental reference for electrical professionals. Secondly, review OSHA regulations to familiarize yourself with the relevant OSHA standards for electrical safety. Thirdly, understand electrical theory, focusing on the underlying principles of electricity and electrical systems. Fourthly, practice calculations to improve your skills. Fifthly, review troubleshooting techniques, studying common troubleshooting scenarios and how to diagnose electrical problems. Sixthly, take practice tests, using online or book-based exams to simulate the actual exam experience and identify areas for improvement. It is important to note that the exam covers a wide range of topics, so thorough preparation is essential. Time management is crucial, as you have a limited time to complete the exam. Always review the exam instructions carefully before starting. For a more in-depth look at each of these areas, let's start with OSHA regulations. These regulations are designed to ensure a safe working environment for electrical workers. Personal protective equipment, or PPE, is a critical aspect of OSHA compliance. This includes items like safety glasses, gloves, and appropriate clothing to protect against electrical hazards. Electrical safety requirements cover a broad range of topics, from proper grounding techniques to safe work practices around energized equipment. Job site safety involves identifying potential hazards and implementing measures to mitigate them, such as proper signage and barricades. Lockout or tagout procedures are used to prevent accidental energization of equipment during maintenance or repair. Understanding these procedures is crucial for preventing electrical accidents. Now, let's move on to electrical theory. This section of the exam tests your understanding of fundamental electrical principles. Basic electricity principles include current, voltage, and resistance, which are governed by Ohm's law. Current is the flow of electrical charge, measured in amps. Voltage is the electrical potential difference, measured in volts. Resistance is the opposition to current flow, measured in ohms. Alternating current or AC and direct current or DC circuits behave differently and have different applications. AC circuits are used in most power distribution systems, while DC circuits are commonly found in electronic devices. Electrical equipment such as transformers, motors, and generators are essential components of electrical systems. Transformers are used to step up or step down voltage levels. Motors convert electrical energy into mechanical energy. Generators convert mechanical energy into electrical energy. Electrical codes, specifically the National Electrical Code or NEC, provide guidelines for safe electrical installations. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, and grounding. Next, let's discuss electrical calculations. This section of the exam requires you to apply electrical theory to solve practical problems. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This law is fundamental to understanding the relationship between these three quantities. Power calculations involve determining the amount of electrical power consumed by a device or circuit. Power is measured in watts and can be calculated using the formula power equals voltage times current, or watts equals volts times amps. Wire sizing is the process of selecting the appropriate size of wire for a given circuit based on its current carrying capacity. The NEC provides tables that specify the allowable ampacities of different wire sizes. Circuit analysis involves determining the voltages and currents in different parts of a circuit. This can be done using various techniques such as series and parallel circuit analysis. Finally, let's cover troubleshooting and repair. This section of the exam tests your ability to diagnose and repair electrical problems. Electrical system diagnosis involves identifying the cause of a malfunction in an electrical system. This may require the use of test equipment such as multimeters and circuit tracers. Troubleshooting methods include a systematic approach to identifying the source of a problem. This may involve checking for voltage, continuity, and resistance at different points in the circuit. Repair techniques involve fixing the problem once it has been identified. This may involve replacing faulty components, repairing damaged wiring, or correcting improper connections. Remember, thorough preparation is key to success on the Connecticut Journeyman Electrical Exam. By studying the NEC, reviewing OSHA regulations, understanding electrical theory, practicing calculations, and reviewing troubleshooting techniques, you can increase your chances of passing the exam and becoming a licensed electrician. It is also important to manage your time effectively during the exam. Read each question carefully and answer the ones you know first. Then go back and tackle the more difficult questions. If you are unsure of an answer, eliminate the obviously wrong choices and make an educated guess. The National Electrical Code, or NEC, is a comprehensive set of standards that governs the safe installation of electrical wiring and equipment. It is updated every 3 years, so it is important to use the latest edition. The NEC covers a wide range of topics, including general requirements, wiring methods, equipment for general use, special occupancies, special equipment, and communications systems. Some of the key articles in the NEC include Article 90, which covers introduction, Article 100, which covers definitions, Article 110, which covers requirements for electrical installations, Article 200, which covers use and identification of grounded conductors, Article 210, which covers branch circuits, Article 215, which covers feeders, Article 220, which covers branch circuit, feeder, and service calculations, Article 225, which covers outside branch circuits and feeders, Article 230, which covers services, Article 240, which covers overcurrent protection, Article 250, which covers grounding and bonding, Article 300, which covers wiring methods, Article 310, which covers conductors for general wiring, Article 400, which covers flexible cords and cables, Article 430, which covers motors, motor circuits, and controllers, Article 440, which covers air conditioning and refrigerating equipment, Article 450, which covers transformers, Article 500, which covers hazardous locations, Article 517, which covers healthcare facilities, Article 600, which covers electric signs and outline lighting, Article 625, which covers electric vehicle charging systems, Article 700, which covers emergency systems, Article 701, which covers legally required standby systems, Article 702, which covers optional standby systems, Article 705, which covers interconnected electric power production sources, Article 725, which covers Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits, Article 760, which covers fire alarm systems, Article 800, which covers communications circuits, Article 810, which covers radio and television equipment, Article 820, which covers community antenna television and radio distribution systems, and Article 830, which covers network power broadband communication systems. OSHA regulations are designed to protect workers from hazards in the workplace. OSHA has specific standards for electrical safety that cover a wide range of topics, including lockout or tagout procedures, personal protective equipment or PPE, and safe work practices. Some of the key OSHA standards for electrical safety include 29 Code of Federal Regulations or CFR 1910.147, which covers the control of hazardous energy or lockout or tagout, 29 CFR 1910.301 through 1910.399, which covers electrical safety related work practices, 29 CFR 1910.132, which covers general requirements for personal protective equipment or PPE, 29 CFR 1926.400 through 1926.449, which covers electrical standards for construction. When studying electrical theory, it is important to understand the basic concepts of current, voltage, resistance, and power. Current is the flow of electrical charge measured in amps. Voltage is the electrical potential difference measured in volts. Resistance is the opposition to current flow measured in ohms. Power is the rate at which electrical energy is transferred, measured in watts. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. This law is fundamental to understanding the relationship between these three quantities. There are two main types of electrical circuits: series circuits and parallel circuits. In a series circuit, the components are connected in a single path, so the current is the same through all of the components. In a parallel circuit, the components are connected in multiple paths, so the voltage is the same across all of the components. Electrical calculations are an important part of electrical work. Some of the common electrical calculations include calculating voltage drop, calculating wire size, calculating conduit size, calculating overcurrent protection, and calculating grounding requirements. When calculating voltage drop, it is important to ensure that the voltage at the end of the circuit is within the allowable limits. The NEC provides tables that specify the maximum allowable voltage drop for different types of circuits. When calculating wire size, it is important to select a wire that is large enough to carry the expected current without overheating. The NEC provides tables that specify the allowable ampacities of different wire sizes. When calculating conduit size, it is important to select a conduit that is large enough to accommodate the wires that will be installed in it. The NEC provides tables that specify the maximum number of wires that can be installed in different sizes of conduit. When calculating overcurrent protection, it is important to select an overcurrent device that will protect the circuit from overloads and short circuits. The NEC provides tables that specify the maximum allowable overcurrent protection for different types of circuits. When calculating grounding requirements, it is important to ensure that the electrical system is properly grounded to protect against electrical shock. The NEC provides detailed requirements for grounding electrical systems. Troubleshooting electrical problems requires a systematic approach. Some of the common troubleshooting steps include: firstly, identify the problem. Secondly, gather information. Thirdly, analyze the information. Fourthly, develop a hypothesis. Fifthly, test the hypothesis. Sixthly, confirm the cause. Seventhly, repair the problem. Eighthly, verify the repair. When troubleshooting electrical problems, it is important to use the proper test equipment, such as a multimeter, a circuit tracer, and a voltage tester. A multimeter can be used to measure voltage, current, and resistance. A circuit tracer can be used to trace the path of a wire or cable. A voltage tester can be used to verify that a circuit is de-energized. Remember to always follow safe electrical work practices when troubleshooting electrical problems. This includes wearing personal protective equipment or PPE, such as safety glasses and gloves, and using lockout or tagout procedures to de-energize the circuit. Effective time management is critical during the Connecticut Journeyman Electrical Exam. To maximize your efficiency, consider the following strategies. Firstly, familiarize yourself with the exam format and content beforehand. This will help you anticipate the types of questions you will encounter and allocate your time accordingly. Secondly, read each question carefully and completely before attempting to answer it. Make sure you understand what the question is asking and what information is being provided. Thirdly, start with the questions you know best. This will help you build confidence and momentum, and it will ensure that you answer as many questions as possible within the allotted time. Fourthly, if you are unsure of an answer, eliminate the obviously wrong choices and make an educated guess. Even if you are not certain of the correct answer, you may be able to narrow down the options and increase your chances of selecting the right one. Fifthly, don't spend too much time on any one question. If you are struggling with a particular question, move on to the next one and come back to it later if you have time. Sixthly, use all of the available time to review your answers. If you finish the exam early, take the opportunity to go back and check your work. This will help you catch any errors and ensure that you have answered all of the questions to the best of your ability. Remember that the Connecticut Journeyman Electrical Exam is designed to assess your knowledge and skills as an electrician. By preparing thoroughly, managing your time effectively, and following safe work practices, you can increase your chances of passing the exam and achieving your professional goals. Good luck.